that day, you know. And of course, we need policy work. We need policy which says, most of the time we say, higher efficacy lamps. We spend a lot of money on higher efficacy lamps. But we don't spend any time on daylighting. And daylighting's already there, and it's already high efficacy. So we have high-level policy goals. In California, we have a policy goal for zero net energy. And zero net energy, great policy goal, and daylighting fits very nicely into this. And we have boiled this into kind of three things. Okay? And I'm going to talk about this a little bit later, but basically three things to do if you want this very aggressive building for sustainability. One is daylighting in all buildings. Just daylighting in all buildings, just straight out. And if you don't use daylighting, you need to write a written explanation why not. And I have found that this is the best way to get things done. Most of the time, people will do something if they can avoid having to explain why they are not. Particularly architects. Architects don't like explaining. Right? So daylighting requirement in all buildings. Vacancy, occupancy controls, and that's what we talked about yesterday. And then demand responsive controls. Controls that will respond to price signaling. That's coming. And the reason why this is important, people respond very quickly to money. And so if you incentivize efficiency, they'll do it. Okay? But notice that daylighting is number one. Should be our number one policy objective across all sectors. It should be daylighting. Okay. We started in this in California with some pretty aggressive suggestions. And in this kind of building, there was a requirement that half of the floor area needs to be in a daylit zone. So you need to put skylights in. Okay? And so there's already initial requirements that when an architect or an engineer builds these kinds of facilities, that it's half of it is daylit. And this was 2005. Come on. I think I missed one. 2014, in the 2013-14, we changed that. And we said daylighting requirements for all buildings, okay? And that at least 50% of the floor area should be in the daylit zone. So this meant residential, hospitality, commercial, schools, commercial. So now there's a daylighting requirement that exists pretty much across the board. And you have to explain by exemption. Now there's exemption that says if it's a hospital room or if it's a surgery space or whichever specialized room, you can avoid that. But even in medical applications now, there's very aggressive use of daylighting in ICUs and intensive care units, very aggressive use of daylighting because they're finding that daylighting is an adjunct to the healing process. So we're seeing even the hospital kind of escape is also being included. So very important as the primary policy move for sustainability is daylighting. So I'm going to talk a little bit about some of the primary strategies. Jesus. Okay. We all know windows. Okay, windows are the side lighting is the primary fixture for the daylight illuminant. And so this is probably the most common. And the idea here is that you're bringing in a certain amount of daylight, it then depreciates across the space, and we call this the normal task plane illuminance gradient. There's a gradient of light across, and it depreciates. It goes from very high to very low. Now this is a problem, okay? Because inside daylit spaces, this is too much light, and this is too little light. Ideally, you'd want the same amount of light across the whole space. So the idea, if you look at work plane illuminance, and this is from yesterday, this is lumens per square foot or lumens per square meter in lux. Okay, I mentioned this is foot candles, but just sort of look at that as lux. And so this is the common kind of distribution going from 100-foot candles, from 1,000 lux back to 100 lux. It drops off very quickly with this type of window geometry. So it means that maybe 25% of the space is in the daylit zone. Okay? So while windows are good to have, are relatively inefficient at providing full room space in terms of daylight. Okay? So to increase the efficiency of this, the distribution, is that you can put in things like these optical devices called light shelves, which are designed to take the light and beam it inside and maximize the distribution. And this is actually what I was working on when I was in graduate school a few short years ago.